All right, good afternoon, everybody. I have 6:31 p.m., so we are going to go ahead and get started. It looks like the number of attendees joining us has started to slow down. We want to thank everybody for joining us here on this cold day to talk about severe weather. So this presentation is going to run about 2 hours, but we are going to have a break in between. And the first part of this presentation, we're going to talk about spotter goals and definitions of severe weather, but that's when we're really going to start to dive into pictures and videos, looking at storms, looking at the structure, identifying those, kind of talking about what the various threats are with the different parts of the storms. After the break, we're going to spend quite a bit of time talking more in depth about the threats, what you can do to report those. So talking a lot about the reporting method really then, and then a little bit mixed in there too, we will also have safety information. We'll do just a very short quiz, just kind of a review quiz. You don't even have to answer it. You can just answer it to yourselves, and then we will wrap up with that certificate there. So moving on in to, first I want to talk just a little bit about the National Weather Service. So we are essentially the federal government's weather agency, providing weather, water, and climate forecasts and warnings across the entire continental and OCONUS United States as well. We have about 122 offices across the country, including our territories of Guam and Puerto Rico. Our office in particular, when we zone kind of down into it, is responsible for the 46 counties that you see on your screen here. We do all the forecast, watches, and warnings for these 46 counties, stretching from the Red River down into Bell and Milam County, including Fort Cavazos. We don't quite go far into East Texas. We don't quite go to Abilene on the west, but whenever there are severe storms, or in the most recent case, winter weather in the area, we're monitoring and issuing watches, warnings, advisories, and forecasts for all of these 46 counties. To do that, we do it with a staff of about 28 people. About 15 of those are actual meteorologists and forecasters doing the day-to-day forecasting, operating the radar, providing that information to y'all when hazardous weather is there. And the other is an incredible support staff with a variety of roles. And because weather never takes a break, neither technically does our office. There are always at least 2 people in the office on shift at all times, 24 hours, 7 days a year. It includes your weekends, your overnight periods, your holidays. So that's Christmas morning, New Year's Eve night. They were there on, even Valentine's Day, but also President's Day, most recently, or Washington's birthday. So there are always at least 2 people there, either doing the required forecast packages or doing a weather watch and providing any updates as needed there. And then, of course, when we do get into hazardous weather, whether it's winter weather like we had now, but for the purpose of this presentation, we're talking about severe weather. So when we do get into severe weather operations, we transition into our watch, warning, advisory mode, and making sure we're issuing properly those severe thunderstorms warnings and tornado warnings as needed. So when we do transition into severe weather operations or even hazardous weather operations, we do have a suite of tools that we use that are very reliable and very powerful, but they do have their limitations with them. So the radar, or the NextRad radar, or the WSR-88D, but most commonly just called the radar, is the most powerful and the most common tool that we use when we are analyzing storms and severe storms in the area. The radar beam can sample at multiple angles and a 360-degree scan, so it can give us really good analysis of the trends of the storm. Where's the hail core? Is the storm intensifying? Is it weakening? Is there rotation in the storm that may indicate possible tornadic development? But as you can see from this picture here in the bottom right, the radar a lot of times cannot sample an actual ongoing tornado. And it can't tell us what size hail is actually reaching the ground. The radar beam itself starts at about 90 to 100 feet above ground. And then the further away you get from the radar, because of the Earth's curvature, the higher up that radar beam is sampling. So the actual radar itself will never sample, our radars will not actually sample a tornado that's ongoing. We have to have that ground truth of what is actually happening on the ground, whether it is damage caused by winds, what size hail, ongoing tornadoes, or flash flooding. So as you can see on the screen on the left too, there are 3 primary radars that we used that provide coverage across our 46 counties. A little bit farther to the east, we have the radar in Shreveport, Louisiana, that covers a good part of East Texas. But for majority, the 3 radars that you see on there are the 3 main radars that we're using to sample these storms across North and Central Texas. So the radar allows us to see inside the thunderstorms, another great tool that we have is satellite with our suite of GOES satellite, taking those pictures from space down to Earth. Now, these satellites are giving us a bird's eye view of where clouds are developing, where storms may be developing, where even fronts or boundaries may be. But the satellite cannot see inside the thunderstorms, and it cannot see underneath the thunderstorms to tell us what's actually happening at the ground. So sometimes we can see storms developing on satellite before they start, or clouds, I should say, before they start to show up on radar. So the combination of the radar and satellite really helps give us as much of a 3D picture as we can get from that tool. But again, neither of that can tell us what's happening actually on the ground. One of the main tools that we have for telling us what's happening on the ground are automated weather stations. And there are several automated weather stations that we maintain, that the FAA and TxDOT maintain. And then for those who we do have access to or who make it publicly known, we can also look at home weather stations. But looking at kind of the picture you have here, one of the pictures of one of our automated weather stations at like an area airport, while they can sample good information like wind speed, temperature, dew point, humidity, things like that, they can't sample certain things. Like it can't tell us if it's hailing or how big the hail is. It can't tell us if there's a tornado. It can tell us if the rain is really heavy, but it can't tell us, if flooding is going on. And typically these are located at area airports. And so when you do get into more rural counties or outside populated areas like the I-35 corridor, then these become spaced few and far between, and there's big gaps where lots of things happening. And so that's really where the combination of the tools that we have, and then on the other side, the people that we have being our eyes and ears, really helps us to have a successful warning program here in the North and Central Texas area. So the pie chart that you kind of see here on your screen, those are a lot of the big players that are communicating, sharing information, watching storms, taking action to protect life and property during severe thunderstorms. Emergency management, of course, they are taking care of their jurisdictions, whether that's city, town, county, or regional state level, helping to prepare for and respond to disasters. The Weather Service, we're doing the radar analysis, we're sharing information, we're taking reports, we're sharing reports, we're communicating as much as we can of what people can expect. And then the media is out there helping us to amplify that information also, because we know that a lot of people turn to the media whenever there is hazardous or bad weather in the area. So they can really help us with message amplification and getting the information out there of where the storm is now, what's expected with it, who should be taking shelter. So our partnership with them is very critical in our relationship too. But then our spotters play a big role in that, and they are actually our eyes and ears out there when emergency management is in the operations center and the media is at the TV station. And the National Weather Service is at, in our facility. We're not out there looking at the storms ourselves. We're not out there storm chasing ourselves. We are in our facility, in our building, analyzing the radar and sending out as much information as we can. So spotters play an integral part in being our eyes and ears out there, telling us the ground truth when they can safely do so of what's going on with these storms. So what you report will be shared and be visible to emergency management and media who are helping us to spread the information and share that message, but know that your contact information is not being shared with them. It would be something as simple as quarter-size hail was being reported near, let's say, AT&T Stadium by Storm Spotter about 5 minutes ago. So that way our partners in Arlington and maybe downstream, whichever way the storm is moving, knows what's happening in their community. People can get on air and they can tell the general public or tell the public what to expect, what is happening with these storms. So timely and accurate reports help us make more informed warning decisions. What you share with us as the ground truth will help us kind of analyze and interpret the radar even better. We'll make mental adjustments if and where we need to. We can increase the hail size, we can decrease the hail size depending on what ground truth report is coming in and what we need to message in our warning. But safety has to be your number one priority. So we're going to talk a good bit about safety, especially as we get into the second part of the presentation. The main goal of the spotters too, not only to keep yourself safe and be the eyes and ears, is also to communicate what you see. So we'll talk about different ways that you can report to the National Weather Service. And that is one thing that I want to remind people on this presentation is that what we talk about here is criteria and guidelines for reporting directly to the National Weather Service. If you are involved in any type of group operations, if you're involved in a spotter group or amateur radio, or if you're with police and fire groups who also operate as storm spotters during an event, you will want to make sure you follow their communication guidelines and their reporting guidelines. Oftentimes it's very close to what the Weather Service guidelines are that we're talking about here, but they can be different, so you do want to make sure that you are following their communication guidelines. Spotters, while they can operate in group setting, they don't have to. So a storm spotter, someone who has been through this presentation that we're in the class that we're doing here tonight, can just report from wherever they are, whenever they are. They don't have to be involved in any type of group or formal operations. We appreciate all the eyes and ears out there helping communicate what's happening in these communities out there. So let's start to transition a little bit now into some definitions. So we've talked a lot about storm spotters actually needing to, my slide will advance, there we go, having something to report. We're going to go through a wish list of what we need reported and when, a little bit later on in the presentation. But when we talk about severe weather, it actually comes in a couple of different forms. So severe weather, the 4 things that you see listed on the screen, all fall within what we call our severe weather program or severe weather threats. So when a tornado is either anticipated within a storm or has actually been detected and confirmed, of course, we issue a tornado warning. Same with flash flooding down there, the last kind of bullet down there. That would get a flash flood warning. But when we issue an actual severe thunderstorm warning, it's not because we think the storm looks scary. It's not because it has a lot of lightning or we just think it might be dangerous. It actually has to meet one of 2 criteria for hail and wind that you see there in the middle of the screen. So a severe thunderstorm warning is issued when it is either confirmed or believed to have hail that is 1 inch in diameter or greater, and or damaging winds near 60 miles per hour. Those 2 thresholds are where we really start to see kind of more notable damage start to occur, and then it increases as the hail and the wind speeds get larger than that. So a severe thunderstorm warning would be because a storm has hail 1 inch in diameter or greater and or is producing damaging winds around 60 miles per hour or greater. So one of the other definitions that we commonly get asked about is the difference between a watch and a warning. So a lot of people tend to think like the watch means watch out, it's happening, do something now, but it's a little bit different in kind of the severe thunderstorm, tornado thunderstorm watches, kind of the weather world, I should say. But let's start over on the left here. Every day, the forecasters are looking at 7 to 10 days, looking for opportunities for where it might rain. And then is there enough for thunder? And then is there enough ingredients for severe thunderstorms? So on a day-to-day basis, we're looking for where severe thunderstorms or thunderstorms in general may be occurring. And we're going to start to refine those details. So we want people to continue to check back with the forecast and stay educated on what days we're expecting severe weather and then what form and what threats those severe thunderstorms may have. On the day where we're anticipating severe weather, at some point there is usually a watch of some kind issued, either a severe thunderstorm watch or a tornado watch. What this means is that conditions are favorable for severe weather. All of the ingredients are starting to come together. One may still be missing, but they're starting to come together where we anticipate that storms will develop soon, or in some cases, they're already developing. They may be developing in West Texas and they're going to start moving east into our area. So we want to give you all that heads up and issue that severe thunderstorm and that tornado watch. What I usually tell people is when a watch is issued, it's okay to continue with your daily activities or doing what you need to do to finish up for the day, but you need to be ready to take action if a warning is issued. So when a watch is issued, it's a good idea to maybe be sure that you're checking the weather, whatever that trusted source is, about maybe every 30, 45 minutes. But as clouds start to build bigger in the sky around you, or as the sky gets darker, if it gets darker, there's probably some stuff happening around you, and you really need to make sure you're in a safe place and start checking the weather a little bit more frequently. Finish up whatever you were doing in case a warning is issued and you need to take shelter in the next couple of minutes or soon after that. So it's okay to continue, but you want to make sure you're keeping an eye on what's going on with the weather. So when a severe thunderstorm or tornado is warning, that means that severe weather is occurring or is imminent. It has either been detected or it's anticipated based on our radar analysis in the area where the warning is issued at your location. So this is when you take action. Do not delay, take shelter, get inside, get everybody inside in shelter, and then you can seek more information from your trusted weather source. So one way that you can try and think of this that hopefully makes this analogy a little bit more easy to kind of conceptualize or grab onto is, hopefully you've seen this graphic before at one point, or maybe you have, but we can look at this in terms of a taco watch and a taco warning, because here in Texas, we do like to eat tacos. So your taco watch, again, you're starting to get all the ingredients together. You haven't quite made the taco yet, but you know, you're getting your tomatoes, maybe your salsa, getting that in a bowl. You're heating up any type of tortillas or shells. Maybe if you're making ground beef, it's not quite ready yet. So like your ingredient isn't quite ready, but everything's starting to get pretty close to being ready to make a taco. And then once the taco is put together there on the right, that's your taco warning. You have a taco, it's ready to eat. Go ahead and eat and enjoy that taco. We don't enjoy storms, of course, but that's when all the ingredients have come together. Now we have a storm producing what we believe to be or know to be hail, wind, tornadoes, or flash flooding. And we want people to take action then and get in shelter and then seek additional information. So when you have something to report, there are multiple ways to report to the National Weather Service. And we'll have this slide a little bit later too. If you do want to snapshot this slide, it's okay, but all this information is on our webpage also. We do take severe weather reports through amateur radio. We have a team of volunteer amateur radio operators that works the various amateur radio lines and different methods and communication technology across most of our 46 counties. You can find more information of them and kind of what frequencies or repeaters they're using on their webpage at wx5fwd.org. You can also follow along and report to us on social media. We are on formerly known as Twitter, now X, and Facebook there on the screen. You can email us reports. You can also email us pictures and videos. You can email us reports after the fact, even if it's a day or a week after. We'll still put it as part of the record, but our webmaster account there in the middle is the main way to reach us. If it's something urgent, especially rotating wall clouds, which we'll talk about, and funnel clouds, and maybe a developing tornado, definitely give us a call. The 817 number is one of the best ways to reach us. And then there is an app on phones that's part of a research kind of grant and opportunity called MPing. It's free. You can report particularly hail, and actually winter weather is good to report on there too, to us through the MPing app. But you can't really write a lot of information or additional information in there a lot of times. So it's not always best for wind damage or tornado and tornadic type damage. Also, MPing reports are delayed getting to our office by about 15 minutes. So use one of the other 4 methods up there instead. And then you still can report on MPing, and we will recognize and kind of know that it's a duplicate report. But you'll be helping a research group and still getting your report to our office too. But that MPing report is delayed about 15 minutes. So urgent reports need to come in through phone, email, possibly social media, and of course over amateur radio for those with their license as well. Okay, we've kind of gotten through a lot of the initial stuff here. Why don't we start looking at the storms themselves, really getting into our pictures and our videos and starting to identify some of the structure. In this video, once all of our ingredients have come together, oftentimes we can get rapid thunderstorm initiation, sometimes along a dry line. And as those storms, or a cold front, so as those storms start to develop and mature, it goes through 3 different stages. So we're going to talk about each of these stages. First, I'm going to introduce them a little bit, and then we're going to look at the actual storm structures and threats associated with each of these stages. So stage 1 is the development stage. This is really where the cloud is developing and all of the air is rising higher and higher up into the atmosphere to form these big towering cumulus clouds, big towering cumulonimbus clouds. We call this the updraft stage also. As you can see by the red arrows, all of the air is rising up, forming cloud particles, maybe starting to slowly condense into rain and hail, but there's no rain, no hail falling out of the storm at this point. Everything is moving up higher and higher into the atmosphere. As we move into the mature stage, Don't get kind of confused, or don't focus too much on this schematic that I have on the right here. This really is just kind of highlighting that there is a lot of things happening in the mature stage. This is where all of our severe weather really happens. So a thunderstorm, a severe thunderstorm, will spend majority of its time in the mature stage. That's when it's going to be these very well-defined thunderheads, these big explosive cumulonimbus clouds like what we see here. And we'll talk about these structures and these features that you see on here a little bit more on the next couple of slides. But the mature stage is where pretty much all the bad weather happens. The hail, the damaging winds, the heavy rain causing flash flooding, and the tornadoes if the environment is right and supportive for tornadoes. A little bit farther down, usually we start to see interesting things happen where the downdraft and the updraft kind of meet. This could be where we see potential wall clouds and tornadic development, but we're going to come back and talk about this a little bit more as we break down the mature stage and look at some additional pictures here in just a little bit. Stage 3 is the dissipation stage, where essentially the thunderstorm just collapses from top down once it runs out of energy or moves into an environment that's not very supportive of it. Sometimes it'll evaporate from bottom up. So everything is kind of raining out of the cloud at this time. There's a few threats still associated with it. We'll talk about those as we get into the second half of the presentation, after we spend some time talking about all the things happening in stage 2, which again is that mature stage there. So let's go furthermore into our pictures now. Let's start working our way from top down. With the cumulus stage, we're going to look more and a lot at what's happening in the cumulonimbus, and then finishing up with that dissipation stage as well. So cumulus stage, again, all of the air is rising up and forming the cloud, rising higher and higher into the atmosphere. So what we usually see in this phase, as a storm cloud develops in an environment that may support severe weather or could support severe weather, is we see this cauliflower-like appearance or this cotton ball appearance that usually, it doesn't tell us that this is going to be a severe thunderstorm, but it does tell us that it's developing in an environment that seems to be well-defined, likely having all the ingredients that we need for severe weather, and it's probably an area or developing storm that we want to continue to watch or keep an eye on. So as you can see in this picture here too, and also in the one in the middle here, you can really see kind of that cauliflower cotton ball look to it. Very sharp, well-defined edges as this storm cloud continues to rise higher and higher, maybe even start to develop its anvil, which we'll talk about here in a little bit. Now, sometimes the environment does not necessarily support good storm development, or at least it doesn't support the development of those tall thunderstorms yet. There could be an ingredient that is still missing. So sometimes you'll see storms try to build and develop and they don't really get very tall, or they start leaning over. Sometimes we jokingly refer to these as turkey towers or kind of turkey legs, but more commonly turkey towers. It doesn't necessarily mean though that our severe thunderstorm threat might be over. It just might be that it's waiting, kind of like our taco watch. We're still waiting for one more ingredient that hasn't shown up yet, that will eventually show up in the next couple of hours potentially. So we're still keeping an eye on the environment unless we know for sure that it's not going to be a day or our ingredients not going to arrive there. So as these thunderstorm clouds do actually continue to grow and develop, let's move into an assumption that we are in an environment that has everything we need for severe thunderstorms. These thunderclouds, these thunderheads will continue to grow and move into the mature stage. And at the very top of the cloud, we will see the development, top of the thunderstorm, the development of the anvil. The anvil marks the top of the thunderstorm where the clouds can't rise anymore. So they start to spread out along that level, forming this anvil, named for kind of like the anvil hammerhead or the anvil hammer shape that it has. But one thing that we can use it to help us for is the direction that the anvil spreads is the direction that the storm is going to move. So for a little bit, bear with me over here. Let's look at our schematic over on the left here. So we talked about the area where all of the air is rising up into the storm. So as the air continues to rise up, it condenses down into cloud particles, then it condenses into rain, and then it further can condense in cold temperatures to ice, which eventually becomes our hail. So as those particles and rain and hail is rising up higher into the clouds, the winds aloft here, kind of near the top of the thunderstorm, are usually much stronger. So down near the surface on days we have severe weather, usually the winds are about 20 to 30 miles an hour. As you get higher up near the top of the thunderstorm, they can be 60, 70, even 80 miles an hour. So as that rain and hail and cloud particles rise up in here, they get pushed with that heavy, strong wind in the direction that the anvil spreads and in the direction that the storm is going to move to. It's being pushed by those higher winds. So that means the rain and the hail also gets pushed towards what is the front of the thunderstorm. And once it gets heavy enough, it falls down, which is kind of marked by these blue arrows and this dark, murky area. So the rain, the hail, the damaging winds, that dark, murky area we associate with storms is actually right along the kind of the front of the thunderstorm, or it marks the front part of the thunderstorm. Whereas the air rising up into the storm, where we have kind of our cloud base, represents the backside of the thunderstorm. So coming back to our anvil, the direction it spreads is also the direction that it's moving. So as a storm spotter, if we can figure out which way the anvil is spreading, it can also give us an idea of which way the storm is moving, which can also help us figure out, is the storm kind of coming at us? Or are we at a safe distance or a safe location? It's moving in a different direction. The anvil itself usually takes on some different properties, but as you can see in this picture taken from space, from NASA there, it also usually has very well sharp defined edges. Not so much of that cauliflower look, but those sharp edges. However, in this area that I'm highlighting here, you may have noticed what looks like kind of a cotton ball, little pocket of cloud or cauliflower look up above the anvil. This is what we call the overshooting top. The overshooting top indicates where the updraft is so strong that it's literally punching through the top of the thunderstorm. Again, seeing an overshooting top, identifying it doesn't guarantee that this is a severe thunderstorm. We can't equate it to the thunderstorm being severe, but it does help us identify where the updraft is, meaning where the backside of the thunderstorm is. And also, usually it tells us that it is an environment that likely could support strong. Maybe the storm is severe, but we don't know for sure until we have ground truth of damaging winds, what size hail is falling, heavy rain causing flooding, or the development of a tornado. Now, overshooting tops are fairly common with storms in our area, so you will see them often, especially with our stronger and severe thunderstorms, and it'll take on different looks. Sometimes they'll seem to extend a little higher up. Sometimes they'll be a little shallower, a little wider, tall and skinny. But again, that doesn't guarantee that this is a severe thunderstorm. It's telling us that the updraft is strong and that it's helping us identify the location of where the updraft is, telling us where the backside of that thunderstorm is. So let's start to come down a little bit more into the middle of the thunderstorm. So we're still on the backside of the thunderstorm, but as we get in closer, we can see that updraft area, that cauliflower cotton ball look, very crisp, well-defined edges. You can see pretty much the sharp edges to the anvil as well. This appears to have a little bit of a cotton ball, kind of cauliflower look to the anvil too. Again, we cannot tell if this is a severe thunderstorm or not. These are just some of the characteristics that we will be able to identify out there, making sure that we're staying aware and monitoring these storms as they move through the area. Now in this picture, the anvil actually is spreading from right to left here. This is the back side of it. You can see more anvil material kind of spreading off to the left here. So this storm would also be moving from right to left, most likely, not directly at us as we're looking at this from a storm spotter. So we hopefully would be in a safe location. But given that, we still want to make sure that our head is on a swivel and that we're looking to see if any other storms are developing around us or behind us too, especially with the threat for lightning with those. So let's kind of move from staying in the middle of the thunderstorm here, moving from the backside up to the front side. If we were in front of the storm, what might that look like? Well, this can be a very common picture from the front side of the thunderstorm. You can see kind of this stacked plate look. Looks like teacup saucers kind of stacked on top of each other. This is what we call striations. Striations are important to know. They don't have to be reported, but they're important to know because the presence of striations tells us that this thunderstorm is rotating. And I'm not talking about rotating like a tornado. I'm talking about the whole thunderstorm is rotating on some scale in the mid-levels of the thunderstorm. Don't think tornado yet. We're still up kind of in the middle of the thunderstorm. So why is that important? Well, a rotating thunderstorm by definition is what we call a supercell. And supercells are important to understand and to identify because usually they result in larger size hail, more damaging downburst winds, and sometimes heavier rain that really can cause dangerous flash flooding. So instead of maybe just quarter size hail, with rotating thunderstorms, hail can be golf ball and larger. Your damaging winds can be maybe 70 miles an hour or greater. But visually identifying this tells you that it is a supercell and that this is a storm you want to make sure you're taking shelter from or staying out of the way of, because its threats are kind of magnified, amplified, or increased, I guess I should say, with these supercells. So if you're at the front, you probably, especially with a severe thunderstorm, a supercell, you would see this. We've looked at the back a little bit. We're kind of going back and forth here, but let's go back to the kind of updraft side of the storm, and let's move in a little bit closer. So as a storm is also rotating, or as it's a supercell, the updraft area may look a little bit more rounded. Especially as you're closer in, you don't really see that cauliflower look to it. It's got more of a smooth barrel shape to it as well. So a little bit of a different structure here when we're looking at those supercells, with the higher threat for larger size hail, more damaging downburst winds, and maybe heavy rainfall as well. But we can identify this as the updraft and the cloud base because we can see right through underneath it. We're going to look at this some more pictures a little bit later, but that updraft area, if we go to our schematic over here on the left, because all the air is rising up into it and there's no rain or hail falling out of that area, we can oftentimes see right through under it. And it has a very smooth appearance to it as well. So those is another clue that we can use to help us identify, okay, I can see through underneath this cloud. Obviously, we've got the storm building above it. This must be the updraft area, or what ideally would be the backside of the thunderstorm. So switching up to the front again, the front in the mature stage is really one of the most important parts of the storm, because this again is where your hail, your heavy winds, your heavy rain is going to occur. This is where the bad stuff is happening. So we call this area the downdraft area because the air is coming down and out of it. So as the storm kind of is dropping its rain, possibly hail with it, maybe some wind rushing down to the ground with it. Once it hits the ground, it can't go anywhere else. So it starts to spread out along the ground. So where we see the rain occurring, sometimes we can see kind of this boot-like look as the wind is pushing that rain and any dust and debris out along the ground with it. This is also where we get the term straight line wind from, because it's moving straight out along the ground. Now, looking at this and identifying this as the downdraft area, and also what we'll call it, you'll hear it referred to as a downburst, maybe even a microburst in some cases. We don't know if this is producing severe criteria wind. We don't know if this is 60-mile-per-hour wind or not. Visually, we can't make that connection. How we would know is we would have to have ground truth, either an automated wind sensor or an anemometer that measured the wind speed, or a description of anything that was damaged underneath that to figure out what the wind speeds may be. So this actually was taken from a tower cam outside of our office. These are new for us this year. It's been providing some great Skywarn videos and still pictures for upcoming sessions. I'm going to watch this downdraft and I'm going to talk over it a little bit, especially since there's no audio here. So I want you to first watch over on the left side here. You'll see new storm clouds developing, starting to form their anvil. You'll see the rain come out under it. And then the downdraft, the storm that we're interested in, is going to come in from the left side. Looking off to the left side, off in the distance, you do see those cumulus clouds developing up. You see the rain starting to form with it. A little bit of anvil taking shape in the storm there, kind of in that left center. New downdrafts occurring with some storms in the back there, but in a second or two here, coming in right from the left side, we will start to see kind of curtains of rain as the downdraft of our storm of interest, there we go, starts to make its way in. Then you kind of see that swoosh. You see kind of that boot-like down around or down along the ground. That again is kind of the front part of that thunderstorm coming in. There could be hail in there. And then right here, it looks like we see another part of the storm collapse and what looks like a bubble of kind of a rain start to make its way down to the ground. Watching kind of those new cells develop, and then right in about the next 5 seconds, we'll see the rain come in from the left again. It doesn't actually kind of hit the tower cam. It's moving off to the side, but you can see kind of that downburst and that downdraft happening. Again, we don't know what those wind speeds are. And then kind of on this right center side, you'll see what looks like kind of a ball of rain drop down right there. That's another part of the thunderstorm collapsing. That's probably very similar to what we would call a downburst or a microburst that could be causing damage and damaging wind off along the ground there. So right along the leading edge of where those winds were moving out along the ground, that is what we call the outflow. It's wind flowing out away from the thunderstorm. You can still see that dark, murky area with the rain, maybe some hail and some stronger winds off on your left side here. Right along usually the leading edge of where this outflow is pushing out away from the thunderstorm, though, we usually see this larger elongated shelf cloud. Again, this marks the leading edge, but this storm, it looks like it has a little bit of a striated look to it, also that stacked plate look to it, but the shelf cloud is going to be kind of a little bit lower to the ground. Sometimes it kind of looks like it's wedged out away from the thunderstorm itself, and it typically tends to follow along with the thunderstorm with those outflow winds as they move across. Now, the presence of a shelf cloud is not something that you need to report, but it helps you identify being in the front part of the thunderstorm. And it helps to identify it, or one clue is that right behind it, it's usually that dark, murky area. So as the shelf cloud moves over you, if you're in its path, then you'll be hit with rain, then you'll be hit with damaging wind if there's anything in it, or stronger winds, and you're going to be hit with hail if there's anything in there too. So the shelf cloud, again, marks that leading edge. It's usually this very elongated cloud that wraps around almost the entire front part and middle part of the thunderstorm. Sometimes we see these interesting little cloud features underneath it that catch our eye. We're going to talk about those a little bit later. We call those scud clouds. They're lookalike clouds. This is not the area where funnel clouds and tornadoes are going to develop. We're more concerned with what's behind that shelf cloud with the rain, the wind, and the hail. And that's our main threats here in the front part of the thunderstorm. So jumping back to the backside of the thunderstorm, as we start to kind of wrap up what we're seeing in the mature stage here, we've already talked a good deal about the cloud base, what we call the rain-free base, or sometimes the updraft base. Very smooth, kind of quiet look appearance to it because all of the air is rushing toward, up, and into the thunderstorm there. So again, we can see right through under it. In this case, this picture, the dark murky area is off to our right here. So this thunderstorm is likely moving in somewhat of a left to right manner. Could be moving still a little bit at us. We'd want to be cautious, especially being this close of the direction of that. But that dark murky area is going to be the front part of the thunderstorm. Our rain-free base was going to be kind of that backside. So you can use those clues to help you see which way the thunderstorm is potentially moving also. Taking a look at these two areas in kind of a wider angle view, we've got our dark murky area indicated where our blue arrows are here on the left side. And then on the right side, it's kind of hard to see because it's a dark picture, but we can kind of see the rain-free base, the base of the cloud over here where air is and the wind is flowing into and up into the thunderstorm. So this thunderstorm would be moving from somewhat of a right to a left direction. So opposite of the previous one, but really lines up with what our schematic on the far right there looks like. All right, so we haven't talked much about the dissipation stage yet, but again, there's not a whole lot to talk about stage 3 because the thunderstorm really just kind of dissipates, collapse. It does have a couple of threats for it, and the threats is what we want to start talking about now. So the development stage, the mature stage, and the dissipation stage all have various threats associated with them and things that you need to be aware of. So as you're using the clues to identify the clouds, as you recognize that it's in the mature stage, what do we need to be concerned about? But first, let's start in the development stage. So even though this is mostly air rising up and our cloud and our storm cloud developing, because you have rain and ice, especially ice, starting to form in the top of the cloud, those ice particles will bump next to each other, which will create a charge, and therefore lightning is a threat as storms are developing. This is oftentimes where the term bolt from the blue can come from. This is oftentimes where a lot of our injuries and fatalities due to lightning happen because all they see is the cloud building. There's no rain. It might even still be sunny out. And so they don't realize that the threat for lightning has already started to occur at that point. So as these clouds are building, we really want to be careful. We want to avoid being outdoors because lightning could occur at any moment during this development stage. So what you guys will see as storms are developing out there is you will see, guys and gals, I should say, you will see the clouds developing and building higher up. In our office, we'll be monitoring as they start to develop on radar, starting to watch their intensity. Do they continue to intensify? Or in this case, this storm kind of intensifies and then gets a little weaker. So something is still missing. It's not quite developing. We'll also be using satellite to see where storms are going to be developing. Where clouds are developing, maybe areas where they're developing a little bit better versus areas where they're not. So which environment is better, and start to message where we might see a new storm development over the next hour or two. So we have covered a bit so far, and we have come to our break, I should say. So we've really looked at the storm structures. We've talked about some of the terminology, what you should be identifying when you're out there. All right, let's go ahead and jump back into our presentation here. So let's get going. Talked about stage 1, but as we talked about so far, stage 2 is really where a lot of the bad weather happens. And so with the mature stage is where we have a threat for flooding, hail, tornado, and wind. So let's talk about each of these. And we're actually going to first start with flooding here. We like to start out with flooding sometimes first because it's actually the #1 killer among thunderstorm-related events. It kills more people each year alone than tornadoes and hail combined. When you look at all of the weather elements, though, heat is actually the #1 killer among weather phenomenon. But for thunderstorms, it's actually flooding. So we oftentimes break flooding down into 3 different categories that hopefully can be relatable. So looking on kind of the far left end of the spectrum here, ponding is what happens whenever it rains. Those areas that were used to water kind of just filling up, whether it's along the curb, low spots, sometimes smaller dips. So you can see in the bottom left there, even construction zones as well is commonly going to have water collecting, but this occurs every time it rains. People usually can still drive through it, not a problem, usually shallow water. In the middle, though, is where we really start to see problems. And the term common and minor flooding, I don't want you to kind of detract from the severity of what that type of flooding can be. But these are going to be the areas that typically fill up with water and present some type of problems whenever it rains heavy or heavy enough, I should say. So this is going to be like your feeder roads, your side roads along of interstates or highways. As you can see kind of in this picture up here too, this would be low spots in roads, maybe where culverts and ditches are, or streams that are small and typically rise and flow over the road there too. So these are going to be your areas that a couple times a year when it rains heavy enough, you do get flooding in these areas. And they can still be dangerous though if a bad decision is made, meaning these are areas we still don't want to go driving into because there could be something under the water we can't see. There could not be a roadway. And or we could end up flooding out the engine if the water gets deeper than we anticipate, or hydroplaning in these areas too. So we still want to be cognizant when common and minor flooding is going on and stay out of those areas and be safe. But when it escalates beyond that to where we have large scale flooding impacts that are an immediate threat to life and property, where people maybe have to be removed or extracted from certain areas, that's where we fall into the category of flash flooding. Flash flooding is typically infrequent in any location, but it can still happen a couple of times a year on average. Not just saying location like where your house is, but maybe the area around you. Think of a slightly larger area than your exact location. This means, though, that people need to take action to protect themselves. So this is where, like I said, people might need to be extracted from certain areas. So when flash flooding is ongoing, we issue the flash flood warning, and these will automatically alert on your wireless devices, your mobile devices, through FEMA's wireless emergency alert system. When we have common and minor flooding ongoing, we usually will issue what's called a flood advisory. Those may not get as much notice as, of course, the flash flood warnings, but it's our way of telling people that, it's not just 1 or 2 trouble spots. We've got a couple of reports of trouble spots happening, maybe even some areas where cars are getting stuck in these low spots. We just want people to be aware and stay out of that area and maybe find a different route. But when there's flash flooding going on, we absolutely need people to stay out of that area, keep themselves safe, maybe even move to higher ground. So as we look at the context of flooding a little bit more, we can, when we're talking about what to report to the National Weather Service, we want reports of common and minor flooding. And of course, we want reports of flash flooding as well. We do want you to send us reports of common and minor flooding, not when it's maybe like 1 or 2 spots, but as the amount of it continues to grow, because especially if we're expecting more rain into this area or into that area, it could quickly escalate to a flash flood warning, and it might be something that we can give people advance notice on so they can start avoiding areas that are already starting to fill up with water and might be overflowing before too long. So a little bit more on some terminology here. Flood watch and flood warning are treated exactly the same as the severe thunderstorm watch and the severe thunderstorm warning. But the big difference is a flood watch can typically be issued well in advance, even a day or 2 in advance. We usually can see the ingredients coming for when widespread flooding or flash flooding is possible and get more of a heads up than just a couple of hours. So you might see that issued a day or 2 before a heavy rain event, even if it comes with severe thunderstorms, the hail, the wind, tornadoes, but giving a heads up. And then the flooding means that it's happening or it's about to happen, it's imminent, and you need to take action at that point. So talking a little bit more about flood safety, we really want to be cautious about driving into or walking into flooded areas. It takes less than 2 feet to move most vehicles. Water oftentimes is a lot more powerful than people think. So if you think about carrying a case of 24 bottles of water, it is not an easy task, or a bigger one, 30, 40 bottles of water. Water is a lot heavier, and when it's moving, it's a lot more powerful than we usually anticipate. So it can very easily, at depths of a foot or less for small cars, and a little bit more than that for your larger trucks and vans and SUVs, it can easily sweep your car off the road and put you in an even dangerous situation. So we have our handy turn around, don't drown. When the road is flooded, we want you to turn around and find an alternate route. Same goes for walking in and being in water. It only takes 6 inches, maybe 6 to 10 or 12 in some cases, to knock a person off their feet and maybe even carry them under or kind of sweep them away with the water. So it's less than that for children. And we especially want to be cautious with children where sometimes our ball fields, our soccer fields, our city parks and playground, nothing against them, but that's just usually where the infrastructure of where they can be put up. They're usually in those lower lying areas where there might be water. We want to stay out of it when it's fast moving water, but we probably want to stay out of it at all time, because sometimes we can't see what might be moving in and under there. And it's not a situation that we want to get ourselves into. So when it comes to reporting flash flooding, you're actually going to see this slide several times. This is when you're making a report of any type of weather to the National Weather Service. If you can answer these 5 questions, you will have given us the most complete report that you can give us, the best description, which allows us to process it faster and put that information out instead of asking a lot of questions back. So I'm going to focus on right now kind of the first 3 here. So what seems intuitive, but people do get excited when weather is happening sometimes, excited in a bad way and in a good way. And we've had people call and say, I see it, or it's happening. And we're like, well, what is it? So remember to tell us what you're reporting. When is important too. Again, we've talked about safety. Keeping yourself safe and taking your safety precautions should be your utmost importance. So if you're calling to report flooding, but this was something that happened a few hours ago when you finally safely made it home, or maybe it was a hail event or lightning took out, your power, your internet, you aren't able to report at that time, tell us when it happened. We do take delayed reports, whether it's 5 minutes, 30 minutes, 2 hours, yesterday, or even last week. As I said, we will put that all in our monthly report and make sure it's documented. Where is a really big one, to be as specific as you can when answering where. You all are the experts in where you live, and as much as Jamie and I and the other meteorologists would like to know about every road and exact location, city, town, within those 46 counties, it's a little more difficult for us to do. So when you're telling us where, if you can give us the nearest intersection, and not just that, but the nearest identifiable intersection, and maybe even as it relates to the nearest city, town, or identifiable area or marker, that will help us find that location even faster. GPS is good. We can plug that in pretty quickly and figure out where that is. But if you call and if you tell me I'm at the intersection of County Road X and County Road Y, it's going to take me a while to try and figure that out, even using mapping software. But if you can tell me that I'm at the intersection of County Road X and County Road Y, which is about 2 miles north of the town of Mejia, then that's going to help me find it faster in the county and know and document exactly where that report is coming from. And then share that information back out with all of our partners and our radar meteorologist as well. So in addition to these 5 questions, when it comes to flooding, there's a few more questions that if you can include in your report, it really is helpful when we're talking about flooding. So flood magnitude, answering the question of how high is high. Now, I'm not asking you or telling you to go into the water and measure how high or how deep the water is, but sometimes we can use the clues and things around us to estimate how deep that water is, whether it's how high up on a vehicle it is, maybe along a fence or bushes or shrubs, that you have an idea of how tall they are. Use those clues around you if you can tell us how deep the water is. And then telling us, is this an area that floods pretty frequently, or is this unusual? Is this something you haven't seen before in that area? Tells us a lot too as we're making decisions about, do we need a flash flood warning, or what other message do we need to be sharing? What other information? And then what's the water doing? Is it fast moving? Is it slow moving, or is it become kind of steady? So fast moving is usually associated with true flash flooding. That's where water is its most powerful and can do its most damage. Usually it settles down when it starts to move into the draining phase. So telling us if it's fast moving, slow moving, or even if it's just kind of steady state, slowly draining is helpful information to the meteorologist at the National Weather Service also. So just a little quiz here. You don't have to put the answer in. Just think about it to yourself. You don't have to type the answer in. But when driving, what action should you take when you come upon a flooded road? Do you test it out? Go ahead and drive on through? Wait for somebody else to test it out, which is what social science tells us a lot of people sometimes do, or turn around? And based on what we've talked about so far, hopefully you have answered C. Remembering the turn around, don't drown kind of slogan that the National Weather Service has to hopefully keep you safe at all times when flooding is occurring in the area. So looking a little bit more at what you guys will see out there, you will see the impacts of the heavy rain and the flooding that's going on, and hopefully giving us as much of a description as you safely can, and not being one of these vehicles that's stuck in the water like this. The Weather Service meteorologists, we're going to be using the tools we have, using the radar and satellite estimates of rainfall to try and pick up on where flooding may be occurring, what the impacts from that rain and that heavy rain is. But having that ground truth, because sometimes the soil is a little bit different. We try to pay attention to how dry or how wet the soil is based on how much rain we've had, how much more is going to run off. But having that ground truth and those local impacts really does speak a lot to us when we are trying to assess and keep up with flash flooding in the area. So let's move on to hail now, kind of our next threat. So when you are reporting hail, you can either give us the actual measurement in inches or quarter inches there too, or you can equate it to a more common household item and you can report that to us also. So you could say that you have golf ball sized hail, or you can say that you have received 1.75 inch hail at your location. Usually about once a year, we do get reports of grapefruit and softball size hail. It's not uncommon in our area, but it's definitely not something that we want to see. So when you are reporting hail, we do ask that you please not send us reports of hail just in your hand without at least telling us what it is, a reference to it, or what the measurement actually is. So hands come in all different sizes. Sometimes it can make a difference, as you can see, whether the hands are kind of, flat as they're holding the hail or cupped like this. So it can be difficult for us to get a good measurement. So make sure you're including a measurement with it, or go ahead and put an object, a common object next to it, whether it's a quarter or a golf ball, baseball, something like that. So when it comes to reporting hail, we ask that you please report hail to the Weather Service when it's penny size or larger. If you think back on our definition for severe thunderstorms, our criteria starts at 1 inch. So the reason that we ask for penny size and larger is it kind of gives us a little bit of a buffer on the smaller size hail, so that if we know that there's penny size hail falling, or even nickel, which is 0.88, then if we see the storm intensify on radar, we usually anticipate that the hail size is increasing also. And if we haven't issued a warning yet, we know we need to get a warning out. We're trying to get lead time on before that bigger hail starts to fall. So on our wish list is penny-sized hail and larger. Now, hailstones don't always fall in nice round shapes like we saw with the hail in the hands a picture ago, and it doesn't always fall in the same size. So when we have, starting at the left here, when we have spiky hail or oblong hail, how do you think you need to measure that? Again, you can just answer this to yourself, but do you want to measure the average length of the hailstone, the circumference around it, or the longest length somehow across that hailstone? And then when you are looking at hail that's fallen in multiple sizes, when it is safe to do so, don't go out where the hail is still falling. When it's safe to do so, and you can go out and pick up a couple of hailstones, do you want to report the average size of those hailstones, the largest size hailstone, or do you just want to pick your favorite one, whatever one looks the prettiest, measure that, and then send your report in? So I'll give you a second to just think about that while I take a drink of water. And as the answers pop up on your screen here, we do want to make sure that we are measuring the largest hailstones, gathering those, and the longest length across. So the longest length may not necessarily go straight through the diameter of the hailstone, but we want to measure as much as we can from spike to spike there. So you can report that a range of hailstones fell, maybe for ½ inch up to an inch, but you want to make sure that you're reporting what that largest hailstone size is when you're making your report to the National Weather Service. So when reporting to the National Weather Service, again, answering our 5 questions. Now we can kind of pull in question number 4 here, measured or estimated. Did you actually measure it? Are you kind of estimating it based on a more common household item? And then is there anything else to report with hail, such as damage of, broken windows, trees being, or leaves being shedded off trees, isn't as much of important as actual damage to buildings, vehicles, and any injuries that may have happened to it also. But make sure you're also answering what, when, where, and then how too. A couple of tips when it comes to reporting hail. We are doing a pretty good job, but we're still asking people not to report marble-sized hail. Marbles come in different sizes. And so we want to kind of be a little bit more specific with the measurement of what size hail it is. Marble-sized hail more commonly used to be equated with ½ inch hail. I think they were using kind of the smaller marble size there. If you look at a hail reporting chart now, ½ inch hail actually is the same size as a plain M&M. So it's a really good excuse to always have plain M&Ms with you. You can use them as a snack and keep a few to kind of estimate hail size there too. We talked about the importance of not sending a picture of just hail in your hand. This happens a lot on social media. If you're going to send us, it's better to lay a more common household object next to it, like we see on the right side here, or make sure you put in the text what the measured hailstone was. So you can also use, of course, your ruler and send in a picture of what that measurement is as well, too. So let's talk a little bit about hail safety. So I'm going to play kind of our, actually I'm going to go ahead and I'm going to skip this video for now. We're going to go to the next one in just a second. But when it comes to hail safety, when we talk about core punching, this is basically intentionally driving into the downdraft or the middle of the storm to find out how big the hail is. Not a good decision, can cause a lot of damage to your vehicle, maybe even cause injury to yourself. We want to stay out of those storms, and when it's safe to do so, after the storm has passed, then we can go outside and we can pick up some hailstones. So we want to make sure that we're staying inside the vehicle or building and not going out when the hail is falling. And so I am going to go ahead and show this video here. Hopefully you have a pretty good idea of what not to do by watching this video.
I know, isn't it something? Big.
So the video does get muted here for a reason too. We see this guy just casually walking with what appears to be large hailstones falling during this.
Because it's going to hit him in the head.
Not what we want to be doing.
If he gets hit.
He doesn't seem to be in a big rush, but the deer is definitely in a big rush there.
Oh yeah.
Be the deer. Don't be the guy just walking out there. As you watch the video, you may have tried to have guessed how big the hailstones are. Visually estimating hail as it's falling is very difficult to do. It usually results in an overestimation. So wait until the hail is done, I promise you, unless it's that pea to maybe half-inch size hail, it's not going to melt fast enough to where you'll still be able to go out and pick up your largest hailstones and make an accurate measurement of it too. And with our last safety tip here, we of course want people to avoid stopping under overpasses, not just during hailstorms, but also any thunderstorm, whatever the threats are. What we see a lot of times is once one person stops to take shelter under there, more vehicles stop to take shelter under there. And then it results basically in a traffic jam where the highway or the interstate is completely blocked. Sometimes we've seen where emergency vehicles cannot get through, they can't respond. And also you see cars that are basically stuck on the highway with nowhere to go. They can't get to shelter themselves. So I know it's unpleasant, especially if it's hailing already, but keep driving, take the next exit or pull off to the road somewhere else. Take shelter. I mean, if you can get out of your vehicle in a sheltered area and take shelter, that would be ideal, but otherwise stay in your vehicle. You may have to protect yourself in case of glass breakage. Hail usually will not break glass until it gets to about golf ball size or larger. However, if it's wind driven, it could happen at anything kind of less than that. But golf ball and larger usually can be enough to smash or shatter a windshield. So if you can protect yourself with your hands or a jacket or blanket or something, that would be ideal. So what you all will see and what you will unfortunately experience is the hail as it's falling. The Weather Service meteorologist, even your broadcast meteorologist, are going to be analyzing the radar, looking for signs of where that hail core is and how big the hail size could be. But again, some of that could melt as it gets down to the ground. So having that ground truth and those measurements like we see on the right side, on the left side there, will help us keep the communities downstream of the storm informed and let them know exactly what's coming at them there. Moving on to our next threat, we're going to talk about damaging winds now. Damaging winds typically occur with two types of thunderstorms. One we've already talked about. This is going to be kind of our supercells or just our regular thunderstorms where part of the storm collapses. We get that downdraft and we have that come rushing down to the ground, and it may cause damage depending on what the speed is. The other type of storm that typically causes damaging winds for us is what's called a squall line. And these are going to be our big lines of thunderstorms that cover multiple counties that come rolling through, usually in the evening hours, sometimes after dark. And with those line of storms, our main threat usually is that damaging downburst winds right along the leading edge of the line there. So when it comes to damaging wind, we're going to go back to our kind of our color spectrum here and talk about a couple of different categories that we see with damaging wind. Majority of our thunderstorms produce about 30 to 50 mile per hour winds. That's usually most common of what we see. Some of the damage that you'll see with those types of winds is twigs and small branches being broken off. Outdoor furniture items, grills, trampolines that are not anchored down, they can still be moved, flipped, or even fly a little bit in winds between 30 to 50 miles per hour. Some weaker fences can be knocked down also. As we get closer to our 60 mile per hour threshold, kind of 50 to 75 miles per hour, this is happens less common overall, but especially in our severe thunderstorms, this is the type of wind speed that we typically see between about 60 or 55, 60 to 75-ish, maybe 80 mile an hour winds. Even at these wind speeds, roof damage begins to occur. We start to see more notable tree damage, even uprooting of smaller and especially larger diseased trees. So that's another thing we have to factor in is the health of our trees, especially when we're in drought years, because it can take less wind to knock them down during severe storm season. It's rare, thankfully, for us to have really 80 plus mile per hour winds. It does happen, but typically when these wind speeds happen, it happens with the tornado. The damage that occurs even from straight line winds is consistent with your EF0 and EF1 tornadoes. We have more extensive roof and structure damage, and this is where healthy trees are really uprooted or kind of blown over. So to give you a visualization of what this may look like, we kind of can transform our color scale here into some damage pictures. So your lighter loose objects, especially ones that are anchored down, will be impacted at just 30 miles per hour. Yes, this can include trampolines as well. We start to see more notable tree damage, as you can see from the two pictures on the bottom, making its way up the scale from 50 to 70, 60-ish miles per hour. Even at 60 to 70 miles per hour, we can start to see structural damage, especially to lighter weight metals like awnings of aluminum material, and even roofs can be peeled depending on how they are attached. And what those connections look like. And then moving higher up in the scale, these were both actually taken from tornado events, because it's been the rare occasion that we have had close to 90-mile-an-hour winds, straight line winds, or 80 to 90 was going to be kind of the North Texas and particularly Collin, Dallas, and Kaufman County event last spring. But we see more extensive roof damage where entire portions of the roof are completely peeled up, including the decking, or cases where the roof collapses or is kind of completely peeled off and you get damage inside the home there as well. So when it comes to reporting winds, kind of along those same lines as what we talked about with hail, if you have a device to measure winds, we ask for wind measurements of 50 miles per hour or greater. Again, if we know winds are at 50 miles per hour and we see the storm intensify, then we can hopefully get a warning out and get some lead time on that. But most people do not have a device or a reliable device to estimate wind speeds. To actually measure wind speeds. And estimating wind speeds visually is near impossible. It usually results in an overestimation of the wind speed. So if you think about it this way, if you are standing on a curb watching cars go by on a busy road, can you accurately tell me how fast those cars are going? And the answer is most likely not. It's very difficult to do. So it's the same with winds. So instead, what we usually want our spotters and the public to focus on is giving us a really good description of what was damaged. Like, how big was the tree branch? How big was the tree? Was it uprooted? Was it broken? If it's a building damaged, what type of building? What's it made of? Is it the roof taken off? Is it walls collapsed? Give us a really good description. It might take an extra minute or two to kind of share all that information, but we can equate that to a wind speed. We'll kind of take it from there and figure out what type of wind speed caused that damage. So quick review on our questions, answering what, when, where, how. A lot of times you might not have the answer of how if it was measured or estimated. Hopefully you're instead focusing more on question number 5 there, giving us kind of a description of the damage and what was the result of that strong wind speed. And we can figure out, what was the resulting damage of that strong wind, and then we can figure out the wind speed from there. So when it comes to damaging wind safety, we treat it a lot like we do a tornado. We want you to be inside, away from windows in case there's any flying debris in those strong winds. Interior part of a house is good, maybe on the lowest floor as well. And then if you're in your vehicle, just know there might be a lot of shaking with your vehicle. If you can, it's best to pull off the road, wait the storm out. If you can avoid even driving into the storm, or you can get out of the path of the storm, that's great too. But there will be sudden changes in visibility, especially as the rain comes in and anything blowing around within there. So you may have reduced visibility during the height of that thunderstorm too. Looking one more time at what y'all see versus what we see, you guys, of course, will see those clues of downburst where portions of the storm collapse. You'll see the damage from it. We're going to be looking for those reports. We're going to be lining them up with what we see on the radar. So the radar not only can tell us where it's raining, but it can also tell us what the winds may be like. It does have limitations on that, which is why when we can match up what the radar is estimating versus what's actually happening, we can kind of make that mental adjustment and make better warning decisions about what to expect. So right here, kind of this bottom middle picture, if my cursor isn't quite showing up, this is what we would call a squall line. That's that big line of thunderstorms. A lot of times it has that bowed shape to it, kind of like a bow and arrow there. And those usually we don't have a large hail with it, but what we do have is very strong winds. In the right conditions, we can have somewhat of a tornado threat, but usually we're more focused on the wind damage that might occur with the strong winds on those squall lines. Moving on to our last and final threat, especially when we're in the mature stage, is the tornado itself. And I do have some videos to show you. A tornado, by definition, has to have 2 criteria. One, it has to be in contact with the ground, and it has to be in contact with the parent thunderstorm. So where are these tornadoes going to form? Well, of everything that we have talked about, the tornado actually forms in that updraft area. So it's a little bit counterintuitive. All of the air is rushing up, but this is where the tornado kind of drops and forms down out of. But it allows us to have usually a good visualization of it because there's no other rain. There's nothing else that usually, for the most part, impeding our view. So oftentimes we can clearly see that rain-free base, and then we can start to see the developing signs of the tornado, which we're going to talk about in the next couple of slides here. But again, emphasizing that this is occurring in that back side of the thunderstorm where that updraft base is, not going to be in the front part of the thunderstorm where all the rain and hail and damaging wind and our shelf clouds are. We're focused more on the back side or kind of the west side of the thunderstorm here. So one of the first stages in tornado development is the development of a wall cloud. So again, we are in the updraft portion, that back side of the thunderstorm, and you will usually see kind of this lowered, somewhat blocky, maybe think of it like a Lego looking cloud developing underneath your main cloud base, that rain-free base that we have talked about, that smooth look to it. Now, if you can pay attention for about a minute here on this, wall clouds actually are fairly common in stronger and even sometimes severe thunderstorms. This is also telling us on the ground where the updraft is strongest, because it's where it's pulling the air in and all of that air is quickly condensing to form a cloud. When the environment is right for tornado development, these wall clouds will rotate. And that's when we really want to be concerned. You may see a few wall clouds, this year or in your lifetime that may not rotate, but it's the ones that are rotating that indicate an increasing tornado threat. This is the area where the tornado will form. It will be underneath the wall cloud. It's not going to be out here on the edge of the cloud base, on the edge of the rain-free base. This is the wall cloud area will be where you want to be looking for our next sign of development. And when they rotate in a counterclockwise direction. So left to right across the front, right to left across the back. And we'll see that in our video here in just a little bit. But again, you may see wall clouds with our stronger or severe thunderstorms in the area. Keep an eye on them. If they're not rotating, they're usually not an immediate threat. But if they do start to rotate, or if they are rotating, that indicates an increasing tornado threat. That needs to be reported to the National Weather Service or through your communication channels pretty much immediately at that point. So the next stage in development is the funnel cloud itself. So the funnel cloud, kind of this little cone-shaped looking funnel cloud or cloud here forming underneath the wall cloud will be basically as this starts to descend down and tries to make contact with the ground. By definition, the funnel cloud is not in contact with the ground yet, but it needs to be closely monitored as a tornado may quickly develop. Now, depending on where you're located, where you live, sometimes our ability to see the ground and to confirm confirmation with the ground is blocked by buildings, trees, other vegetation, other cars on the road sometimes, if we're kind of looking at it off of and afar. But we still want to report the funnel cloud and the rotating wall cloud and continue to, if we safely can, monitor for any signs of contact with the ground, which is going to be debris or dirt, dust, anything being kicked up, maybe even above this tree line off in the distance here. So as the tornado starts to take shape, it'll go through 3 stages of its life cycle. This video I'm going to pop out here in just a minute, and this one does not have any audio, so I am going to talk over this one. So your audio should be good, but let's go ahead and get this one started. So this video is not a time lapse. This is in real time. You can see the counterclockwise rotation, left to right across the front, right to left across the back. So this is our wall cloud right here in the middle of the screen. Of course, you can see kind of a disorganized funnel, but right here, this has made contact with the ground. This by definition is a tornado, and the funnel itself the condensation cloud has reached all the way to the ground. Now, as you continue to watch this video, you'll see that the tornado kind of lifts, and then it'll almost redevelop again. And that's common in the initial stages of development. It's still considered part of the track, but this storm is essentially still getting its act together. As we continue to watch it here, again, we don't see contact with the ground until about right now again. And then at this point, it really starts to take off. You can see how fast it develops. It starts to widen. It's gaining strength and intensity, and it's starting to move into the mature stage at this point. So let's move on and let's look at the mature stage next. I won't be able to talk over this one because of the audio, but this is a tornado in its mature stage. This is where the tornado probably spends majority of its lifetime. It's its strongest. It's usually its widest, doing its most damage at this point. This is usually during the time when it gets its highest rating. So let's go ahead and take a look at this one. So we do thank Connor for this video, but we ask you to not be this close to tornadoes. Hopefully you can be at a much safer distance, or you should already be in shelter if the tornado is this close to you. So again, the tornado was very much kind of upright. You can see the damage and the debris being kicked around, not immediately around the tornado, but well out away from it too. So even the wind field and the debris and damage can be thrown I've seen it up to a mile sometimes away from a tornado, tossed away just by the sheer power and intensity. Tornadoes are rated based on what they damage, so the rating cannot be done until after the tornado has happened and the Weather Service has had a chance. It's another one of the jobs that we do, has had a chance to go out and assess the damage and determine how strong the tornado was to cause that type of damage. So I have one more video of a tornado in its mature stage that I'm going to play. This one does not have audio, so you should be okay to leave your volume as is. All right, this video again is not time-lapse. This is in real time. This is an example of where the condensation funnel does not reach all the way down to the ground, but we can clearly see contact with the ground by the dust and debris whirl being kicked up. If you look up at the cloud base, you can get a sense of that counterclockwise rotation. You can also kind of see what looks like thin wisps, kind of those dark clouds that are moving with the wall cloud and kind of moving up into the cloud itself. Those are those look-alike clouds. Those are those scud clouds that we talked about. They help us to trace the wind, but they change and they move very rapidly, usually not maintaining the same shape. So they're not a funnel cloud. They're not a developing tornado. This, of course, is still a damaging tornado. It moves a lot slower than the one we saw in the previous video, and that's okay too. We would have to take a look at the damage to see exactly what the rating was and how strong the winds were. So let me jump back into our presentation here real fast, although I think I still have one more video to show because we've already looked at these. So we've talked about the mature stage. So now we're going to move into the dissipation stage. So this one does not have very loud audio either. Your audio should be fine, but let me launch the dissipating tornado. But essentially in the dissipating stage, the tornado shrinks in size and becomes what we call rope-like or snake-like. It's still on the ground doing damage. Usually the damage is a lot weaker. Usually more lightweight objects are being tossed around. But from this point, the tornado will almost kind of dissipate up into the cloud itself or almost break apart from the middle out. We've already talked a little bit about those scud clouds, but again, we kind of call them imposter clouds. They can really catch your eye, maybe make you think that there's a funnel cloud or a developing tornado, and it would definitely be something you want to keep an eye on. But usually these kind of shift and change very rapidly. They have that ragged appearance and they move with the wind, so they'll usually become part of the storm or disappear pretty quickly. Keep an eye on it, but know that it might just be something playing tricks on your eye. And it usually does not have any rotation associated with it. Real quick, another one of the imposter clouds that sometimes people confuse for a wall cloud is actually that shelf cloud on the leading edge of the storm. Our wall cloud, remember, forms on a much smaller scale underneath that rain-free base. These shelf clouds can be very much elongated, covering the entire front part of the thunderstorm. So it's not a really big wall cloud along that leading edge. We can always remember that right behind that shelf cloud, that elongated shelf cloud, is that dark murky area, helping us to identify that area of the storm as well. So keep that in mind. Remember, those wall clouds are going to form under smaller areas of that smooth rain-free base. Kind of starting to wrap up our tornado portion here, talking a little bit about tornado safety. Again, I really hope that this is reminders for you, but when it comes to tornado safety, underground is best, but underground is not always an option. So we want to be on the lowest level, small interior room. Usually a bathroom, a closet, maybe a laundry room is best, but staying away from windows and putting as many walls between you and the exterior of the home, whether it is a brick home, a manufactured or mobile home, or anything like that, is best. And take something to protect yourself in the case that you do get impacted and there's flying debris. When it comes to vehicles, they pretty much become toys to tornado wind. So we want you to abandon your vehicle for a sturdy shelter. And again, do not shelter under overpasses for any type of severe weather that we have talked about here so far. Looking once more, or I should say one final time, at what you will see versus what we will see. A little advance here, there we go. Hopefully you're at a safe distance. If you're not at a safe distance from these tornadoes, you should be taking shelter. But if you can, reporting what you see with that developing and rotating wall cloud. the funnel cloud, and then the development of the tornado itself, the radar is going to be measuring or indicating rotation associated with what might be a tornado. And sometimes it can give us clue of debris being kicked up in the air, but that ground truth really does tell us is what we're seeing on radar actually happening on the ground out there. So those real-time reports are critical when you can safely do so in fast evolving situations. I'm actually going to skip through this slide right here. It's a lot of the same there and move on to stage 3. So our last stage and the hazards associated with it as the storm dissipates, there's still a lightning threat. Usually there's still some type of gusty winds. It might not be overly strong, but there might still be some gusty winds happening out there. And then remnant flooding from any ongoing flooding that may have been happened might take a couple of hours to drain away. So we still want to stay out of those flooded areas and off those flooded roadways there too. And that really starts to wrap things up for us. We still got a few things to do, but to summarize, if you want to take a snapshot of this also, please feel free to do so. But this is our criteria for what we need reported to us at the National Weather Service. So we want to know about flooding, any type of rapidly rising water into areas that typically don't flood, something that's uncommon. For hail, we want penny-sized hail or larger. For winds, if you can measure 50 miles per hour, but most people, I want you to focus on describing the damage that was caused by those thunderstorm winds. And then any sign that a tornado is occurring or maybe about to develop, including, as I mentioned, that rotating wall cloud and that funnel cloud too. Quick review too, reminder, answering your 5 questions here of what, when, where, how, and any additional information or magnitude you can provide gives us the most complete report, allowing us to process that, put any new information into our warning, share it out, and get prepared for the next warning or updating the warning farther on. So focus on hopefully answering these questions to give us a very complete report. I actually want to go through a little bit of a quiz. Let's see how we did. Let's see if we can, there we go. Let's see if we can kind of wrap up what we learned about and see how we did it and what we've learned here today. So I have, I think, 7 questions here. And again, you don't have to type your answers in. Think about these to yourselves. I will reveal the answers to you. So looking at this picture here, a simple question is what's going on here. Maybe a better question is what are some of the features that you can identify from this picture here? I'll give you 1 minute to kind of look it over and think about the storm structure that we've talked about so far. All right, so some of the features that we can identify here, this is actually, come on, the shelf cloud associated with the outflow, that leading part of the front part of the thunderstorm. This is kind of a wide angle look at a shelf cloud. It's hard to see how it kind of slopes down and away from the thunderstorm, but you probably saw some of these ragged clouds that caught your attention. Those scud clouds, something you could keep an eye on, but again, they're usually very fluid, very shape-shifting, and can just kind of trace the wind. So do you need to report any of this? Short answer for that is no, unless there's wind damage or hail behind that shelf cloud that meets our reporting criteria. So remember, once that shelf cloud moves over you, you usually will be hit with the rain. There could be hail and damaging wind in there. If you've got something to report from that, then please let us know that. But we don't need to know specifically that the storm has a shelf cloud or what's happening along that leading edge. All right, what's going on here? Definitely some water over a roadway here. That falls within our flooding category. Do you need to report this is a good question. And the answer to this would be yes, especially if this is something that's uncommon or if there's property or life impacted from this or life threatened. Now, this water appears to be probably slow moving. The sun is actually out, so the storm could have passed. This might be after the fact, and this is water that's still draining. But it does kind of look like there may have been a creek on the left side or some body of water that maybe rapidly rose and flooded over this roadway over here on the right side. So this could have been a previous flash flood situation, and now this is the after effect. But just from the still picture, definitely if there's property impacted or life threatened, then you want to report it if this is something uncommon that you don't see a lot in this area. All right, what's going on here? What are some of the structure? What would you report if you were looking at this kind of off in the distance? This is a funnel cloud. Whether it has contact with the ground is a little difficult to see from this distance. It does appear to extend pretty close to that tree line, but I don't see any evidence of debris being kicked up. Here we have our well-defined wall cloud. This one's a little bit bigger than some of the other pictures we've seen, but we have a clear look through it in that updraft area. So should you report this? And the short answer to that is yes. A tornado could happen at any moment if it's not already ongoing, which a spotter from a different location may have a different vantage point and is calling to report that there is damage and debris ongoing on the ground. All right, let's take a look at this picture here. What's going on here? Think again maybe about the storm structure that we've talked about. What are some of those features that you can identify on this picture? Kind of revealing our answer here, this appears to be the look of striations, that stacked plate look. So associated with a supercell, that rotating thunderstorm in the mid-levels. This is a better look at a shelf cloud, even down along that leading edge. So we're looking at that front part of the thunderstorm, not the area we would anticipate or expect tornadoes to form. But as this storm moves over us, there could be hail and damaging wind occurring with it. So as we talked about, the structure itself, you don't necessarily need to report, but if you do observe hail or damaging wind that meets our criteria, make sure that you report that to us when you safely can do so. So what do we think is going on here? Some type of damage. What was it caused by? Don't necessarily know yet. So we can categorize it as thunderstorm damage. Was this straight line winds, a downburst, or was it a tornado? We obviously would need more context, more information about additional damage in the area, maybe a ground survey even to know exactly what caused this damage. So should you report this to the National Weather Service? Yes, absolutely. But I want you to just kind of stop and think for a minute of how would you describe this? Like, how would you give a good description of this so we could understand what exactly was damaged? Oftentimes things like this get reported to us as a building demolished or a building destroyed. And that doesn't maybe necessarily paint the whole picture. Yes, this is heavily damaged, but this is a better description might be, damage to what looks to be like some type of aluminum or metal barn. It does have some I-beams in there that appear to be maybe bent. Probably the roof was taken off and the walls collapsed as part of that, but a lot of the material inside that barn or storage shelter is still in there. So those are some of the things that you could use to help describe this type of damage to us. I think we're at our second to last question here. My screen again is not catching up, so I'm going to give it a minute. But if you do see it, start thinking about, hopefully this one's a dead giveaway of what is going on in this picture. This is a tornado on the ground, causing damage on the ground. I mean, you can see kind of our funnel cloud extending down to the ground here, a condensation cloud, and the debris being kicked up kind of on that right center part of the screen. Hopefully you know the answer of should you report it, and yes, absolutely, report this as soon as you can to the Weather Service. Last quiz question here. I want to know what's going on here, but more specifically, I'd want to know what you would be reporting to the National Weather Service using this image alone. Some of you might be using some background radar skills that you have, identifying some radar features, but I will tell you that this is evidence of a supercell on radar. Do you need to report this to the National Weather Service? And the answer to that is no. Never report what you see on radar to the National Weather Service. We want you to tell us that ground truth of what you're seeing with your eyes or hearing with your ears instead. That radar data that you're using is the same radar data that we're looking at. And we have years or decades of experience interpreting that and using it to issue the warnings. But we need that ground truth from our storm spotters instead to make the full puzzle picture or have a good understanding of the full puzzle picture of is what the radar telling us what's actually happening at the ground. So use the radar to keep yourself safe, to see which way the storms are moving, but to the Weather Service instead, report what's actually happening on the ground in that real live ground truth there. And that is bringing us to the end of our presentation here. We've already talked about our reporting methods earlier, but just a quick reminder,